Hey everyone. Thanks for having me at the conference. Super excited to be here. I'm gonna do a short talk today on the context engineering stack, which is one of the up and coming discipline in AI engineering. My name is Alessio. I do a lot of things. So I host Latent Space, which is the largest AI engineering podcast. We've been doing this since the beginning of 2023, and we've had guests from every top AI lab, AI native companies, and whatnot. We focus specifically on people building with AI. So if you're a practitioner, you'll find a lot of valuable information then, and I'll link some of the most important ones later on. I also run Kernel Labs, where we do startup creation, and a firm called Decibel, where we invest in AI native founders and in cybersecurity. We're also investors in Cube, funny enough. So super double excited to be here today. So some of you might have heard the term RAG, retrieval augmented generation. As my friend Jeff nicely put it, RAG is dead, context engineering is king. It's the same thing. I think there's obviously, engineers love to name things, even though naming is one of the hardest problems in computer science, as people say. But I think there's an increased interest in what we put into a model context window. So in the beginning, when models first came out, it was all about how do you fit the information that you care about when you only have a few thousand tokens. So, and for those that are not familiar, maybe when you if you can see here on the in this kind of like chart, you see these things in different colors are called tokens, and it's the way that large language models kind of structure data. So tokens can be a word sometimes can be part of it, but basically, when GPT-3 came out, for example, it had a context window of about 4,096 tokens. That means you can fit roughly, 16,000 words, something like that. And so this number kind of keeps growing. So when you go to today, you have some open source models like Llama 4 that have been fine-tuned to take 10 million tokens in their context window. Most of the offerings from the large labs are around 1 million. So Claude 4 and 4.5 both support 1 million context window. I believe some GPT-5 variants do it. And then Gemini also has it. So I would say the ability of the models to take more and more tokens as input has grown. And we'll kind of break down what counts towards the number. And you'll see that, we're quickly increasing the ability for models to take more tokens, but the quality of the responses based on the amount of tokens in the input keeps decreasing. So this is from a great piece of research that the Chroma team has done around what they call context rot. So I think maybe in the beginning, the hypothesis was like, okay, today we have 8,000 tokens in a context window. In the future, we'll have 1 million. And so we just put everything in the context window. We don't have to worry about doing RAG or doing context engineering. This is obviously not true. So if you look at, these are the top models, and obviously GPT-5 has come out since this, but there's not as big of a difference. All the models are very good at the first, kind of like thresholds of input lengths. So when you're looking at, 100 to 1,000 tokens, they're very, very good at keeping track of everything in there. As the amount of tokens in the context window increases, you get worse and worse performance because the models kind of get confused by things, especially when there's, conflicting things. There's also a tendency for the models to get anchored to tokens that are already in the context window. So even if you have, for example, you ask a question, you get the wrong answer, and then you try and go back and forth with the model trying to get it to do something different. But the way these models work, the previous tokens really influence where the model goes next. So by having kind of bad tokens or tokens that are not as useful, you're actually having a big impact on the quality of the model. And so this is why context engineering is becoming so interesting to people, because it helps kind of limit some of these issues. If you look at a context window, so this is from the Cloud Code UI, Jeffrey Wang, who's the founder of Exa, tweeted this out yesterday, I believe. And they have this new UI where you can see, what is the context made up of. So you basically have system prompt. So that is, you're a helpful assistant, blah, blah, blah. You have system tools. So what tool calls can the model make. Then you have MCP tools, like what MCP servers are exposed to this model and what tools do those servers expose. You have memory files, which are like, agents.md and kind of like these instruction files that are user-based. And then obviously you have the conversation itself, which are the messages. And then the auto compact buffer. This is basically, as you run out of context, the model is going to summarize the conversation and kind of like shrink the context. So you need some buffer for that to happen. And we'll kind of break down these one by one. So I think we can use that as an example. If you're building analytics agent and you wanted to answer questions about, data, what should that look like and how would you architect each of these pieces? So system prompt. This is, I'm not going to read it. You can kind of like, take a look as I talk through. But the idea of the system prompt is what is the inner dialogue in the brain of the agent? So, these are things that are like core to the personality and are not really about the task that it's doing. So, kind of like saying, hey, you're like an analytics agent and you answer questions about data. It's not really about how the data is going to be presented necessarily. It's not about what kind of data goes into it. This is just about the highest level. Hey, just make sure you do this. The system prompt is always present. So there's no way for any of the users to like remove from the system prompt. So you always want to make sure that the system prompt is like very tight and doesn't interfere with the requests that the users are going to have after. Tools. So for those that are not familiar, you might not have built an agent before. What you can do is, outside of obviously the messages that go back and forth, LLMs are able to take tools as input. So you can think of tools are basically like code. So for example, this is a function called getWeather. This getWeather is a function that is defined in some code base. So it can be a Python function. It can be, just looking at, the snake case it's probably what it is. And so instead of asking the model to do things in the latent space, so to speak, instead of like thinking and coming up with an answer, they can use tools to get, more structure and idempotent things. So in this case, for example, this is something that the model just cannot know, right? What's the weather? But for a lot of queries, you need that. You need that knowledge. So you write a getWeather function, and then you use this OpenAPI JSON definition to put to pass to the model. And so in the future, if you ask the model, what's the weather in Rome, it's going to do getWeather, and then it's going to pass Rome as a city, and then it's going to pass either Celsius or Fahrenheit. And again, this depends on the context. What's in the context? Does it say where the user is based, as the user asked specifically? So all of this is context. Like descriptions are context. Like the better the description, the better the model is going to be at using it. Same way units, it's like you could do, you could not have a enum here, right? And you could just say unit and unit of the temperature, and then the model is going to come out with it. But what if the model passes C instead of Celsius? What if it passes, you can see how this can break. And so thinking about structuring tools is actually one of the most important things in building an agent. And you can look at Anthropic has like some great blog posts on building effective tools for agents. We did an episode with some of their team around their coding agent and how to build tools for coding agents. So again, everything is context. So whenever something goes into the LLM, you should really think thoroughly, am I giving one too little or too much information? Is it accurate? Is it ambiguous? You want to limit that as much as possible. MCP tools are basically the same thing, but instead of you writing them in your agent code, users can bring MCPs to your agent. Usually an MCP as, now most of them are hosted remotely. So the user is going to put a URL, which looks like, example.com/MCP. When the client asks the server, what tools do you have, is going to return a list of tools that look just like the one that we just showed. MCP servers can also show prompts. So for example, there can be example prompts that are passed by. It can have its own system prompt that it passes. And so this is a way for, if you're building an agent that you want to expose as an MCP, and I've seen some of the companies that I work with do it where they have an internal MCP that is kind of like pre-written prompts for their own system or data querying. And then you have resources, which are data. So you can either call a search tool, or you can call a SQL query tool, for example, or you can even put a kind of database in the server. And so you're not doing the SQL calls every time to a live database, but you have them preloaded. And that's one way where you can do a lot of work on kind of like RBAC and security by having some of the data pre-filter before it gets to the user and avoid the models to make mistakes. But again, the more MCPs you put in the model, the more tools that get exposed. This is kind of what we talked about before. So, if I have a run SQL query tool and the user asks how many users logged in at least twice, the model is going to do this tool call called run SQL query and write the query that it thinks it should use. This code runs somewhere. The model gets back a structured response from it, and then it uses that response to answer to the user. And all of these things are also stored in the context. So all previous tool calls are part of the context. They're not ephemeral. So again, this is like another thing to really think through. The more tool calls get made, even though if the conversation is short, there could be a lot in the context that is given issues. So yeah, we kind of talked about this, but basically like the system tools, you build them and you own them. They cannot be turned on or off. So if you build an agent and you give it system tools, those are always on. It's not like an MCP that you can like remove or add. And so similar to the system prompt, these should be things that are like always applicable. So web search, for example, running code, things that are not related to any particular use case. It's always better to have those things tied to like a separate MCP or like a sub agent or things like that. MCP tools, all of those tools are executed remotely. So you don't necessarily know what goes on in the code itself. So there's a lot of security implications for that people are working on, but just something to keep in mind. They can be, by conversation, you can add or remove one. And these are great for highly specific stuff. So for example, if you need to get Twitter data, you might put, the Twitter or X APIs in one MCP, and then that MCP comes in or out depending on if it's necessary. Common mistakes, tools that are too broad, it's like ask me anything. The model is going to get confused about when to use them and what to use them for. Also having tools that basically put all the complexity in the arguments. So for example, instead of having, use Twitter API and then you can pass any endpoint to it, that's very prone to the model not understanding what the arguments are, like how to structure that. So instead of doing that, you want to have individual tools that are like, hey, search Twitter, and then you put the query as an argument, post to Twitter, and you put the post as an argument. So this is one way to think about context engineering. Again, the more of these things get into context, the more the model can get confused. And then overlapping names is something that happens more and more with MCPs. If people developing the servers are not really thinking about overlap, you might end up having a bunch of these MCPs that are like generic tool calls like get record or like delete entry, blah, blah, blah. And so what you can do on the client side is basically you can prefix the tool name with the name of the server to diversify them. But again, it's better to like really be thoughtful when building these things. So again, going back to like our analytics agent, what you would do is build tools like, execute SQL query, where you can pass a query and you can pass a database ID, and you're relying on the model, obviously, to write a good query. There's a lot of things that you can do there to make that better. That would be, even like with the cube semantic layer, obviously, is like instead of having to come out with all the schema and like all the dimensions, you kind of have these like predefined things. Again, it's all about narrowing. Like you want to make the model choose. You don't really want to make the model think and like be super creative, especially when it comes to like things like this. And in the tool description, this is like another example. You don't want the user to need to pass the database IDs. You want some of these database IDs to be predefined. And so you're limiting the amount of calls of like bad things that can happen where like the agent calls the wrong database. And you're also making it easier for the model to not hallucinate what database to call. Rendering a matplotlib chart is like a great example, right? What you could do is you could give it a run Python code tool. That could work too, and like the model might get it right. That's great. Or you can create a function that is like, very narrow, that is more about just preloading, matplotlib and having kind of like some sane defaults, and then you're limiting the model to just returning a specific file format. And so again, these are like all ways to think about, do you want the model to have to decide what plotting chart to use? Because it might say, okay, I ran the query and I'm going to use chart.js to make a chart, but like you don't want that. And so, the more freedom you give to the model, the more it can kind of go off the rails. Obviously, there's the flip side of that, which is like, hey, if I don't know what I need to do, then I want to give it more generic tools. But I would say, when you know exactly what you need the agent to do, it's always better to try and limit the choices that it has. Memory files are like another kind of like standard that people are working on. So agents.md is like the most popular name for it, for coding agents. And again, the convention is just literally the name of the files. Like you can put whatever in the content. So calling it a standard is maybe even too much, but these are for user specific things. So if you think about the system prompt, that's like what the model and the agent itself need to know. The flip side of it is this is what the user specifically asks for. So as an example here, it's like, if it's an international company, in my agents MD, I'm gonna put, hey, I work in the European division of the company. So for example, do not look at data for North America, use euros as the currency, format dates in this way. And these are things you would not put, for example, in the system prompt. One mistake you could do is like, if the user is in Europe, format things this way. If the user is in Europe or in the US, format things this other way. You don't need that context for everybody, right? So by using that, you're kind of just wasting tokens and like potentially confusing the model. So all of these things should go into the user kind of like memory files. And you can also provide these files to the user. So, just like in a Git repo, you have some defaults for like specific files, like a .env. Like you might have the same thing for your agent, which is like, hey, this is like the default agents.md, and these are the things you should put in it. But then the user can go in there and customize as much as they want. And then the last part is context pruning and compaction. So again, the more turns you have in a conversation, the more the context grows. So one thing you can do at a basic level is like ask the agent to summarize the conversation, and then you basically like just dump all the existing messages, and then you create a new conversation where the first message is like the summary, and you say to the model, hey, this is the conversation that you're in, continue the conversation from here. That's something that Claude Code does, for example, and like a lot of these coding agents do. It's not super, it's not amazing because the model itself doesn't necessarily always know what matters in a conversation. And so it might be mistaken there. A better example is to have different files that can be plan.md or like progress.md where the agent can write to and kind of like keep track of what it's doing and what it needs to do and what the user preferences are. And so at any time you can kill the conversation, restart a new one, say, hey, look at progress.md and see where we are. This is also a good way to do it. And then for tool calls, as I said, all the tool calls are in context. So what you want to do, especially when you're doing a lot of SQL queries and things like that are pretty verbose, over time you want to start pruning the tool calls. So, like in the previous example, we asked how many users logged twice, right? We get the data back, the model responds, hey, these are the 10 users. You can now remove the tool call data because the information itself, it's already in the conversation. Again, there's a lot of work to be done here to understand which ones are useful to keep, which ones are not. But this is something that most people don't think about context. They think of context as like the messages, not about everything else. So I will really make sure that you spend some time thinking about how the purging and compaction of your agent works. And then to wrap, some homework. If you want to learn more, we have 2 great episodes of the podcast that you can listen to. One is with Jeff Huber, founder of Chroma, gracious host of our podcast. And we talked about, ragged that context engineering is king. And then we did an awesome episode with Lance Martin from LangChain about context engineering for agents. We talked about all of these different compaction strategies. We talked about different ways to handle memory for agents and similar things. So go on YouTube and find those if you want to learn more. And then you can just add me on @Fanahova if you have any more questions. But thanks again for having me, and hopefully this was helpful.